Hello everyone. In this video, we will be seeing exercise 1.3 first sum. So now here we will be seeing exercise 1.3 first sum, in which they are saying write the following in decimal form. So we have to convert this number into decimal form and say what kind of decimal expansion each has, and we have to comment like saying what kind of decimal expansion these numbers have got. So we will divide this number. Okay, now. So 36 divided by 100. So the numerator number will always come inside this bracket. Now here we'll write the denominator. So now if we see in this number, what we have to do is we have to divide this smaller number with a bigger number, and that is not possible. So what we need to do is we need to make this number little big so that we can divide this with 100. So how can we, so to make it little big, we need a zero here. If we want a zero here, then we need to take a decimal here in the quotient. Then we can go ahead and add a zero here. Now we can divide it with 100. So 100 threes are 300 we can do. So 100 threes are 300, right? So what will remain now? 60 will remain. Now again this number has become smaller when compared to 100. But now for the second time we have to not give any decimal point because already the decimal is taken. It is taken only once. So once, if you have already taken the decimal, you can take, for the second time you can take the zero directly. Okay, now 106 is the 600, right? So now when we get a zero, when we get a zero in the remainder, this is remainder, when we get a zero in the remainder, it means then this answer has become our final answer. This question is our final answer. So therefore, okay, what is our answer? 0.36. Now this 0.36, what kind of decimal expansion it has got? In the introduction video I have explained everything. Okay, if you have not seen that video, you have to go and see that video first and then come to this video. Now this decimal expansion is called as terminating decimal expansion because it is stopping at 6. After 6 it is not continuing. So when the decimal expansion stops, such kind of decimal expansion is called as terminating terminating decimal expansion. So they have asked us to convert this number into decimal form, which we have done here, and they have asked us to name what kind of decimal expansion it is. It is terminating decimal expansion. So this is our answer. Okay, now we'll see the second sum. Now we'll see the second sum. Okay, we'll divide this number. Okay, we'll make a box here. So one numerator will always go inside the division bracket, and we'll write the denominator here. Now if we see here, we are trying to divide a smaller number, okay, with a bigger number, which is not possible. So what we need to do is we need to add 0 and make this number big. So to do that, if you want 0, then we need to take a decimal here. Now we can add a 0. But even after taking a decimal and adding 1 0, still this number is falling short when compared to this number. So we need one more 0 here. Now if we need one more 0 here, then for the second 0, okay, we need to give 1 0 here after the decimal. Then we are allowed to take one more 0 here. Now if we see here, this number has become bigger when compared to this number. Now we can divide it. So 11 nines are 99, right? So minus, so 1 will remain. So one time 0 is allowed because we have taken the decimal. But even after adding 1 0, still we cannot divide it. So we need another 0. It means one more 0 we need to take here. Now we can take another 0 here. Now the same story will repeat. So again, you know, 11 nines are 99, and again 1 will remain, and this story will continue. This story will continue. It means what? 090909 is repeating. So what is happening is, so what is happening is 0.09, and we'll write a bar like this. Or you can write 090909, and you can give dot also like this. Like this also you can write. So if you write 0.0909 and dot dot dot, that is also okay. Or 0.09, and if you know, then the group of numbers which are repeating, if you give a bar on those numbers, it also means the same thing, that these group of numbers are repeating. Now here, what they had asked us to find the decimal form, we have found out. The second thing what they are asking is to name what kind of decimal expansion it is. See here, the decimal is not terminating, but it is repeating. It means it is non terminating, non-terminating, recurring. Okay, non-terminating, recurring. So this type of decimal expansion is what? Non-terminating, recurring. Okay, all right. Now next sum we'll see on next page. Now we will see this third, sum. Here they have given mixed fraction. Okay, we have to convert it into a proper fraction. So denominator into this number we have to do 8 4s are 32, and then after multiplying we need to add this numerator part. So 32 plus 1 is 33, and then again write the same denominator like this. So now it has been converted into a regular fraction. Now we will divide this. Okay, so we will divide this. So the numerator part will go inside and the denominator will go outside. Now, so 8 fours are 32, right? So 8 fours are, we can divide like this. So 1 will remain. Now 1 is falling short. We cannot divide it. So we need to take a decimal, a decimal here, and then we can take a 0. We are allowed to take a 0. Now 8 ones are 8 we can do. Now what will remain is 2. So already we have taken decimal. So 1 times 0 is, we are allowed to do take one 0 here. So 8 8 twos are 16 we can do. So 8 twos are 16. So what is remaining is 4. So 1 times 0 we are allowed to do. And 8 fives are 40 we have. 8 fives are 40. Now what we are getting is, we are getting 0. Once we get a 0 in the remainder, it means we have solved the fraction completely, and this is our answer. The quotient is our answer. So 4.125 is our answer. Now here what is happening is, the decimal expansions have stopped. Once they stop, it means what? The decimal expansion is terminating decimal expansion. Terminating decimal expansion. Okay. Now we'll see the next one. Now we'll see the fourth sum here. So 3 numerator will go inside and denominator we have to write outside. So now if we see here, this number is a small number, so we cannot divide a smaller number with a bigger number. So we need to take a decimal here. Now we can go ahead and, oh sorry, I cannot write 2 here. So I by mistakenly I wrote here 2. So just add a 0 here, but I will take a decimal, okay, and write a 0 here. Now see if we can divide it. Yes, this number has become a bigger number now. So 13 we can divide now with 13. So 13 twos are, yeah, by 2 only we have here. So 13 twos are 26. So we will minus this. So what we'll get is 4. So one time already decimal is there, so we can add a 0 here directly. So now 13 13 threes are. So 13 threes are is 39. So we will get 1 year. So add a 0 year. Now if we see here, still after adding zero, still this number is falling short. So for the second one more zero, if we want, then we need to take one zero here in the question. So now we are allowed to add one more zero here. So now 13 sevens are 13 sevens are 91. 13 sevens are 90. So we will have 9 here. So take one zero. So 13 6 is the 13 6 is the 78. 13 6 is the 17 and 12 will remain 1 0 we are allowed to take and 13 nines are 13 nines are 170. So 3 will remain. And if we see here, already we had started with 3 only. So again, if I bring one 0 here, again the same story is going to continue. Again the same numbers will continue, right? So we can stop here. Okay, we can stop here. Again, the same numbers will be continuing, right? So the decimal expansion is what? We can write our answer here 0.230769 and we will draw one bar on this. Okay, it means the numbers are repeating in this group. And what kind of decimal expansion it is? See, the numbers are not terminating, but they are repeating. It means they are recurring. It means it is non-terminating, non-terminating, recurring, right? Recurring. All right. Now we'll see the next sum on the next page. Now we'll see the fifth sum. Okay. So numerator will go inside, denominator right outside. Now this is a smaller number which cannot be divided. So we need to take a decimal here and add then take a zero here. Now we can divide this. So 11 ones are 11. So how much will remain? 9 will remain. We can take one zero here. Already decimal is given. So 11 8 is 11 8 is 88. So 2 will remain. Now if we see here, 2 again we got 2. So again the same story is going to continue. So these same numbers are going to continue, right? So this is our answer. So we can draw a bar like this. So 0.18181818 like this it will be continuing. So what kind of decimal expansion it is? Definitely it is not terminating. So it is non-terminating, non-terminating, and but it is repeating. So it is non-terminating, recurring. All right. Now we'll see the next sum. Now we will, see this last sixth sum. So 329, divided by 400. So now this number is, smaller compared to this number. So we need to take a decimal here and add one zero here. Now we can divide it. So 800, 400 into 8 is 3200. Subtract this. So what we'll get is 90. So already decimal is there. So one zero we are allowed to take. So 400, twos are 800. So how much will remain? One will remain 100 will remain, right? So this number is falling short. So one zero we are allowed to take. So 400 again, twos are we can do 800. So 200 will, remain here. So we can allowed to take zero here because already decimal, we have taken. So we can add one extra zero here. So now 400 fives are. 405 is 2000. Now what we are getting is 0, the decimal, in the remainder. Okay, so this is our final answer because we got a 0 in the remainder. So 0.8225. Now, so if we see this number, the decimal expansion is stopping. It means it is terminating. Huh? It is getting completely divided. So it is terminating decimal expansion. Terminating decimal expansion. So this completes our question number 1, which had 6 sub questions. Guys, to motivate me, please like, share, comment, and subscribe my YouTube channel. And for online tuition classes, visit this website. Thank you very much, guys.